Hey, good morning, everybody. This is Mr. Ainsworth, and we're going to get into your second semester final review, which covers chapters 1 through 6. Okay? So it might help you if you take chapters 1 through 6 notes out and get those organized. So if you don't have those, and if you don't have a red pen for annotating all the key points here, then stop the video right now and get out your chapters 1 through 6 notes so you can use them effectively. And also get out a red pen here so you can put all your key points in red. All right, let's get started here. And by the way, this is a video, so if I go too fast, go ahead and pause, play, rewind, use the video effectively, okay? And if you need to listen to it more than once, well, you have the opportunity to do it because it is a video, okay? All right, let's get started. Interact with me, okay? All right, once again, this is your Math 90 second semester final review. All right, let's get right into it. So we got 3 minus 4 minus, times the quantity, 4 minus 1 to the third power times 4. Well, you want to follow the order of operations. So let me see, what do I have? 3 minus 4 minus, well, 1 cubed is 1, all right? Okay, 1 cubed is 1. 1 times 1 times 1 is usually 1, all right, times 4. What is that? Well, we got to multiply before you subtract. So this is 3 minus 4 minus, well, let me see, that's 4 right there. All right, 4 minus 4 is usually 0, so you have 3 minus 0, which is 3. By the way, when you do this here, at the end of this right here, I attach the answers. So go ahead and use your answers and check your work as you go. Always good to do that. Okay, let's see here. Speaking of that. Okay, let's try another one here. All right, so in the fraction here, we got 8 plus 3 plus 7. Well, 7 plus 3 is, that's 10. 10 plus 8 is 18. All right, 1 plus 2 is usually 3. And when you take 18 divided by 3, you get 6. All right, so follow the order of operations here. All right, next one, you're going to have to evaluate an expression. All right, so what you do is you substitute your values in first. All right, so you got negative 6 is equal to negative 6 plus y, but y is negative 6. Right, plus z is 5, times whatever x is squared. So you take negative 2 and multiply it by negative 2 squared. Well, negative 6 plus negative 6 is negative 12. A negative plus a negative is a negative, bigger negative. All right, plus 5 times 4, because negative 2 squared is 4. So you get negative 12 plus 20. All right, 20 minus 12 is 8. All right, so this one is equal to 8. There you go. All right, simplify. Okay, distribute through the negative 4, so this is equal to 12. Negative times a negative is a positive. All right, plus negative 4 times 3 is negative 12a. And you can write that simply as 12 minus 12a, or in standard form be negative 12a plus 12 in standard form. Okay, same thing here. You got to distribute the number first, okay? Always distribute first. So let's write that down. Always, all right, distribute first. So here we go, negative 54, all right, plus 54p. All right, there's a double negative right there. All right, and you got to distribute through the negative 7, so minus 14p, all right, and then minus 14. All right, and then you got to gather up your like terms. So this is equal to negative 54p minus 14p. All right, and then you got a negative 54 here. All right, and then a minus 14. You have to regroup like terms. All right, and then step 2, you got to finally, you're simplifying the result. Why? Because you always simplify your expressions in mathematics, right? Okay, so these two right here, in the two groups, let me see, negative 54p minus 14p is the same thing as negative 54p plus a negative 14p, which is a negative number, right? Negative 68, so negative 68p, all right? And the same thing here, double negative right here, so you got a negative minus 68 right there. Okay, there we go. So, let me pause the video here. Oh boy. Okay, so I thought I made a mistake here, so I'm going a little bit too fast here in the morning. I got to concentrate. Okay, 54p was a positive. All right, so I'm gonna change that here. I just have to fix that little mistake right there. It's positive 54, and 54 take away 14 is not negative. Okay, so 54 take away 14 is 40. So you have 40p. Sorry about that. I just brought down the wrong number here. Got to be careful and check your work, obviously, because even me, I got to check my work because I'm human too, just like you. All right, here we go. Solving now. Okay, solving the equations. Always do the inverse, okay? N divided by 15. So the inverse of division is called multiplication. So you multiply both sides by 15, all right? And simplify 15 divided by 15 is 1, okay? N times 1 is typically N. And 15 times negative 9 is negative something. And then you just figure out what 15 times 9 is. So that's 90 and 45 or 135, or you can do it the old-fashioned way and multiply here, all right? And then you get 135, so 100, negative 135. Okay, and this one takes a few steps here. You want to add the opposite first, so I'm going to add a negative 7. And I get 3 is equal to n divided by 2, and then it's pretty much the same as the previous one. You got to multiply both sides by 2, all right? Always the inverse. If you're dividing by 2, then multiply. All right, and you get 6 is equal to n here after you simplify. And the number 8, you want to distribute a couple times first. Or you can divide by 2 if you want. That's probably faster. Most of you guys would probably distribute, so I'm going to do it your way. Okay, so 2 times 6k is 12k. All right, minus 2. 2 times 1 is 2. Add the opposite, and you get 96 is equal to 12k. Divide by 12. All right, and you get k is equal to, well, it's probably 8. 8 times 12 is 96, so k is 8 right here. All right. So, you got to be able to solve some basic equations, including the inequalities. So on this one here, just like I did on the previous one, all right, you want to multiply by 6, all right, simplify. And what do you get? You get 6 times 19, so 19 times 6, multiply. Right, you get 9 times 6, 54. All right, 114. That's 60 and 54 is 114, which is right here, right there. All right, so what do we get? We get 154 is greater than n, which means n is less than 154. So my final solution is a graph. This does not include 154. Or excuse me, why did I say 154? It's 114. I'm making very simple mistakes here, guys. I'm just not reading my handwriting right correctly. So it's 114, not 154. All right. Oh, man. I'm having a hard time this morning. So n is less than 114. And so it doesn't include 114. So n is not equal to 114. It's not a solution. So we go open. All right. Open circle. So open here. All right, and all numbers less than 114 lie to the left. So it's an open circle here because n does not equal to 114. It has to be strictly less than. All numbers less than 114. Okay? Okay. On the next one here, we're going to add the opposite. So we get 10 is greater than or equal to a v divided by 2. Multiply by 2, just like on the previous equations. And you get 20 is greater than or equal to v, which means v is less than or equal to 20. Now 20 is a solution because of the equal to portion here. So there's 20 right here. So we're going to go closed here, and all numbers less than or equal to 20 exist to the left. Okay, this is less than or equal to, so v is or 20 is a solution. So go closed. So if you see the equal sign, it's closed. If you don't see the equal sign, it's open. It's that simple. All right, so open at 20. All right, same idea here. All right, we're going to subtract 3 first. All right, and we get x divided by 7 is less than 2. Multiply by 7, and you get x is less than 14. So 14 is not a solution. So we're going to go open there, and all numbers less than 14 exist to the left. Now this one's a little bit more challenging here, so we're going to distribute through the -4 first. Okay, excuse me for a moment, just checking something. There we go. Should be in tablet mode. All right, so -81 is greater than or equal to -24 minus 16n. You got to distribute twice, and then minus 3n. And then you got to simplify. So -81 is greater than or equal to -24 minus 17n. Okay, minus is another bigger minus, right? If you subtract 14, you subtract 3, you're subtracting 17 in all. Add the opposite. All right, and then what do you get? You get -57 here. It's greater than or equal to -17n. And then you divide both sides by a negative number, and you got to be careful here. Whenever you divide by a negative, you got to switch the inequality. So let me see, 3 times 17. No, that's not correct. I made another mistake here probably. 50, 70, 81. Let me just check my math here. Oh, come on, Ainsworth. -4 times 4 is -16. Okay, so -16 and -16, -3 is -19. There we go. So let me fix this here. So -19n here. So we want to divide by -19 instead. That's what happened. Okay, so when we do that, you get 3 here. So 3 is greater than or equal to n. Nope, you got to switch the inequality. So let me put that in red. You have to switch the inequality when you divide by a negative. Okay, switch inequality. All right, when dividing by a negative. Okay, now because of this right here, let me rewrite it here. If 3 is less than or equal to n, that means n is greater than or equal to 3. Okay, and that is the solution right here. So here's 3. All right, we're going to go closed at 3 and to the right. Okay, it's greater than or equal to 3, so 3 is the solution here. Okay, and remember the key idea is right there. Okay, on this one here, we're going to solve for x, so let's highlight it and let's see how we're going to handle this one here. So x is in the denominator. So the first thing I'm going to do is I'm going to add the opposite. I'm going to isolate the fraction. All right, so I get g plus y is equal to c divided by x. Okay, and I don't want the variable in the denominator, so I'm going to multiply both sides by the denominator to clear the fractions. Got to clear the fractions here. And so what I get is x times, all right, g plus y is equal to c. Now I'm trying to solve for x, and x is being multiplied by g plus y. So all we do is divide both sides by g plus y, and I'm done. So x is equal to, all right, c divided by g plus y. All right, these quantities cancel to 1. Anything divided by itself is 1. Okay, and this one's a little bit easier here. X times k equals w plus v. And if you solve for x here, since it's being multiplied by k, all you do is divide both sides by k. Right? It's that simple. It's a one-step equation. So you get x is equal to w plus v divided by k. All right, now on these compound inequalities, they have 3 parts. Okay, so whatever you do to one part, you do to all parts. So the very first step here, and again, this let me highlight here for a second. So we got, oh, I better not do that. It's too dark. Okay, so you have a left, and you have a middle, and you have a right. So what I'm going to do here is isolate the x by subtracting 1 first from all 3 parts. So what do we have? So 101 minus 1 is 100, greater than or equal to 10x now. The negatives cancel out, obviously. Greater than -39 and -1. That is a -40. Okay, so now you just divide all 3 parts by 10. So it's just like equation and inequality solving, just it has 3 parts versus 2. So you have 10 greater than or equal to x, which is greater than -4. All right, and then you reverse the inequalities here. So this is the same as -4 less than x, which is less than or equal to 10. So this is all numbers between -4 and 10, all right, including 10 but not -4. So we're going to go open at -4, closed at 10, all right, and all numbers that exist in between. So x is between -4 and 10 and including 10. That's why it's closed here, all right, as opposed to it's open here, because it can't be equal to -4, so all numbers between. Now this one here, a little bit more simple, but you just got to be careful here because the negative number, we got to divide everything by a negative 10, all right, and switch the signs of the inequalities. Okay, so we get 7 greater than m, which is greater than or equal to -7 here. And again, once again, switch the inequality. -7 less than or equal to m, which is less than 7. Here in this case, all right, so this is going to be all numbers between -7 and 7. And so the -7 is right here. Okay, and then 7's over here between 6 and 8. So we're going to go closed here. I'm going to go open here. And all numbers in between. Okay. So some more equation solving here a little bit. I'm going to do a few of these, not all of them, and then you guys can check your answers with the ones that I provide. I'm going to get onto the second part of the video here. Okay, on this one here, multiplying both sides by 13 would be appropriate because the inverse of dividing by 13 is multiplying by 13. All right, so let's do that. Let's multiply both sides by 13. Okay, always do the inverse. And then here you get 13 times 16, you got to multiply. And when you do, you get -208, so -208. I'm going to do one down here, okay? I'm going to skip down to 25. Again, I'm not going to do everything in the review here. I'm going to just do all the key examples. Okay, and you guys could check your work on the rest of them and use what I tell you on the ones that I do to help you with ones that are similar to it. Like 25 and obviously 26 are similar, right? These are similar. So if I do 25, then you guys should be able to do number 26 because it's the same idea. So on this one here, you have -25 is equal to -6r, right? You got to distribute, all right, plus a -24r because you got to distribute twice, or you can write it as a -24. So -24 here, and then distributing through the -7 here, you get -7r, and then a -42 because the negative times a positive is a negative. Okay, I'm going to regroup. So I got a -6r and a -7r, and then a -24 and a -42. All right, regrouping. Why? Because you can only multiply like terms. So you get a -13r here and a -66 here. All right, add the opposite. And you get, let me see, that's 80 and 11, 91 is equal to -13r. And divides both sides by -13. All right, and then hopefully that's divisible. If not, we write it as a fraction. All right, and then and what do we get? We get -7 because 7 times 13 is 91. And you can check that too, by the way. So once again, use your skills. I'm going to do most of the problems in the review, but not all. All right, and then so take these ideas and apply them to the other equations. Like on number 22, all you do is distribute first, which is what I've been talking about. And 21, you got to distribute first. Okay, just like I was doing in number 25, and like you're going to do in number 26. Okay, moving on. These are similar. Okay, so but they have different slopes. So the slope, let's write down the slope-intercept form first. Y equals mx plus b. All right, m equals slope. All right, b is the y-intercept. So over here we have m equals -6/5, which means we go down 6, right 5. B is equal to -1 on the y-axis. Okay, it's called a y-intercept. So we start down here at -1, and then we go down 6, right 5. So down 6, right 5 is off the graph. That's okay. Down 6, 1, 2, 3, 4, 5, 6, and then right 5. 1, 2, 3, 4, 5. So it's approximately here. Let's reverse it though. Let's go up and left. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So we go up, all right, up 5. We got to go, excuse me, up 6 because I reversed it, right? And then left, all right, left 5. That's the same thing as negative 6/5. And so when we draw our line, see if I can do it okay on the computer here. There we go. All right, you get your line. Now this equation is a little bit different, obviously, but it's the same idea. Here the slope is 2, which is the same thing as 2 over 1. Y-intercept's negative 3, or 0, negative 3 on the graph. So you start here at 3, excuse me, negative 3. And then you go up 2, 1, 2, right 1. Up 2, right 1. And you repeat your slope. All right, as I show you guys in class, we always repeat the slope. And then reverse it too. So your slope, positive slope, always goes to the upper right. All right, this is positive slope. Okay, upper right, always. Okay, negative slope, okay, lower right. Okay, now these equations are a little bit different. They don't, one doesn't even have slope. But you got to think, you know, where is y always equal to negative 5? So let's start on the y-axis. Okay, let's find negative 5. So that's positive 5 up here. Negative 5 is down here. Okay, so where is negative 5 on any point? Where is y always equal to negative 5? Well, the most common mistake people make is they think that this right here, because it's y equals negative 5, they think it's vertical. Okay, but if you plot this right here, if you plot a vertical line through negative 5, you know, here y is negative 1, here it's 2, here it's 3, here it's 4. So clearly a negative line here doesn't show you where y is negative 5. Y is negative 5 here. And it's also y is negative 5 here. 1, negative 5. 2, negative 5. 3, negative 5. Y is always negative 5 on this line, a horizontal line. All right? So just because it has a y variable doesn't mean it's vertical like the y-axis. You got to train your mind to think the right way. Where is y equal to negative 5? In fact, let's write that down. Where is y? Okay, the y-coordinate, all right, negative 5. All right, and it exists on this line, okay, not a vertical line. Same thing in here. You got to figure out where is x equal to 4. So you look at the x-axis, which is this horizontal axis here, and here's 4. So x is equal to 4 here. If 4, 1, x is equal to 4. 4, 2, 4, 3, 4, 4, 4, 5. X is always equal to 4 on a vertical line passing through 4. All right, so you find 4 on the x-axis, and then figure out where the other points contain an x-coordinate of 4. Like I said, this is 4, 1. This is 4, 2. You can, if you write down the coordinates, you can see this. That right, this point is 4, negative 2. X is always equal to 4 on this vertical line. Now these two right here are in standard form, so you want to get them in slope-intercept form. You want to solve for y. Okay, so let's do that. All right, use a little bit of algebra skills. So always add the opposite first. And you get 2y is equal to negative 3x plus 4, because 4 is positive. Divide everything by 2. And you get y is equal to negative 3 halves x plus 2, where the slope is negative 3 halves and the y-intercept is 2. Now when you have a slope of negative 3 halves, it's down 3 right 2, starting at 2. Okay, so you start at 2 on the y-axis. Okay, plot the y-intercept first. Okay, plot first. Okay, and 0, 2. Okay, and then go down 3, right 2 using your slope here. Okay, so you go down 3, 1, 2, 3, right 2. 1, 2, 3, right 2. Reverse it. Up 3, 1, 2, 3, left 2. And then you draw your line. And as I said earlier here, all right, any number that has a negative slope always goes to the lower right. All right, this is negative slope. The other way is positive. Okay, now the same thing here. When you have x plus y is equal to negative 5, you subtract x first or add the opposite, and you get y is equal to negative x minus 5. So if you compare to slope-intercept form, you see that the slope is negative 1, which is negative 1 divided by 1. So you're going to go down 1, right 1. All right, starting at b, which is negative 5. So you start at negative 5, and you go down 1, right 1, and then you're off the graph. So you reverse it, up 1, left 1, up 1, left 1. Okay, and you reverse the slope. And then you simply draw your graph after that. Okay, and that is number 32. Okay, moving on. Some inequalities right now. So these right here, you got to sketch the half plane, sketch the graph. Okay, these are half planes. All right, they're inequalities. So on this one here, we don't have a y-intercept, but we have a slope. Okay, so I'm going to write down the slope. The slope is negative 4/3, which is down 4, right 3, starting at b, which is at the origin, 0, 0. All right. Now, it's strictly less than. Okay, so these are inequalities here. It's strictly less than, and because of that, right there, I know that it's going to be a dotted boundary line. BL stands for boundary line, and because of that, because it's less than, okay, you're going to be shading below. Okay, solutions are below, so it's dotted and below. So the first thing I do is I graph the y-intercept at 0, 0, and I go down 4, right 3, down 4, right 3, and then reverse it, up 4, left 3, and then I draw a dotted boundary line. Okay, there's your boundary line. Now this is an inequality, and all solutions lie below the line. So here, the solutions lie below the line. So we call this the solution region. Okay, so on number 33, the solutions are off the line and below. It's called the solution region. Inequalities have solutions that lie either below or above the boundary line, and so it's basically half of the plane. Okay, below, everything below this boundary line right here. Not on the boundary line, but below. Okay, and the same thing here on this one. This one's a little bit different. The slope's negative 3/2. So negative 3/2, down 3, right 2, starting at b, which is 2 in this case. Okay, or 0, 2. So you find 0, 2, and you go down 3, 1, 2, 3, right 2, down 3, right 2, and then reverse it, up 3, left 2. Ooh, there's my donkey. Okay, and it's going to be dotted boundary line here again, but this case, it's going to be a little bit different right here. Right here, the boundary line is going to be dotted, all right, and the solutions are above, so it's going to be dotted and above because of the greater than symbol. So we're going to shade above the boundary line. Okay. All right, now these are a little bit more challenging only because these right here are in standard form, so you got to solve for y, okay, or you got to isolate y. All right, so let's take this 2x plus y here and less than or equal to 1. And let's get it into slope-intercept form. So let's subtract 2x. All right, you get y less than or equal to negative 2x plus 1. All right, the slope's negative 2. And the y-intercept is 1, so we're going to go down to or right 1 from 1. So we're going to start here at 1. We're going to go down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. You can reverse it, up 2, left 1, up 2, left 1. All right, and then it's going to be, looking at this right here, it's going to be solid and below, solid boundary line, and below, because a less than means below, so we're going to go solid here. And the solutions lie below the boundary line, so it's the half plane below. we call this the solution region. And if you don't draw this right here, then you don't know what you're doing basically, because the solutions lie on the line and below the line. Okay, it's that half plane. Okay, and next one here we got 3x minus 2y greater than or equal to 10. Same idea, subtract 3x. Be careful here, it's a minus 2y, so bring down the negative 2y greater than or equal to negative 3x plus 10. Divide everything by negative 2. Okay, so divide everything by negative 2 and switch the inequality. So y less than or equal to, look at that, switch the inequality from greater than or equal to less than or equal to. All right, these negatives cancel out and you get 3 halves x minus 5. So the slope's 3 halves and the y-intercept's negative 5. So on this one here, we start at negative 5 and we go up 3 right 2. Up 3 right 2, up 3 right 2. Now looking at this, it's going to be solid and below. So we're going to go solid here. And the half plane is going to be below the boundary line because it's less than and not greater than. So here's my solution region. So in all inequalities, okay, you have half planes. All right, equations like the ones above, on previous ones like these right here, these are equations. They're just, the solutions are strictly on the line. They're not off the line. Okay, they're equations. It's difference. Okay, but when you have inequalities like less than or greater than, or less than equal to or greater than equal to, you have solutions that lie below the line. All right, moving on to systems. Okay, graphing, solving by graphing first. Okay, so we graph them. So this solution here, the solution is the intersection. That's the key idea on this right here. Solution is the intersection, okay, of the lines. Key concept, okay, of the two lines. So we got to locate that. Where is the intersection? That's how you solve it by graphing. So we're going to graph the two lines and then find the solution. It's the point that they have in common, right? Because the solutions are on each line, but the solution to both lines is the one they have in common, which is called the intersection. Okay, so here the slope's 1/4 and the y-intercept's negative 3. So we're going to go up 1, right 4, reverse it, down 1, left 4. I suggest you do these with a straight edge right here. And the second line, we'll do this one blue here. So the slope's 2 and the y-intercept's 4. Starting up here at 4, we'll go down 2, right 1, down 2, right 1, down 2, right 1. What happened here? Gonna make a mistake here already here. What'd I do? Oh, going the wrong way. Slope's 2. So slope, come on Ainsworth, slope's 2, right 1. Okay, right 2, up 2, right 1. Starting at 4. So starting at 4. Okay, you got to go up 2, right 1. So it's off the graph. So we're going to go left, or down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1. There's the solution. Okay, you got to go positive slope here. All right. So this is line B, and this one's A. So there's the intersection. So negative 4, negative 4. So my solution is negative 4 comma negative 4. It's the intersection, as I was saying earlier. It's the intersection of the two lines. All right, so you just got to get experience on this, right? So the slope here is 1, y-intercept's negative 3. So slope of 1 goes up 1, right 1. And what I suggest you guys do is plot a bunch of points, because when you do that, and you can see where they intersect a whole lot easier here. So this is A, line A. And then B, let me see, slope's negative 1/2 and the y-intercept's 3. Negative 1/2. So down 1, right 2. Down 1, right 2. There's the solution right there. Okay, it's always the intersection. So 4, 1. All right, now numbers 39 and 40, same idea, but they, in standard form. So this one right here, y is equal to negative x plus 4. And then this one here, you're going to have to do a little bit more work. So let's go ahead and solve for y here. 5x minus 3y equals 12. Subtract 5x. You get negative 3y equals negative 5x plus 12. Divide everything by negative 3. You get y is equal to 5/3 x minus 4. So let's start graphing here. So slope here is -1 at 4. So -1, down 1, right 1, and plot multiple points. So this is line A. There's line A. B. Okay, this one's B. We'll call this one B. Down at -4 here, we're going to go up 5, right 3. So up 5, right 3. There's your solution. Okay, so the solution there is 3, 1. Okay, now number 40 is just like it. So you give it a shot and check your answers on the back. Okay, now these are a little bit different, so I'm going to do one of these. So this one here, we want to graph first. All right, and it's the intersection of the regions on this one. So the intersection of the regions. So I'm going to do it in 2 colors, okay? So on this one here, we'll do in red, and this one we'll do in a different color. So this one's red. I'm going to start at 3 and go up 1, right 3, and reverse it, down 1, left 3. And this right here tells me that it's dotted and above. The solutions are not on the line, but they're above the line. That's what I'm saying here. Okay, so there's the first one. Let me switch colors here to green. So let's start at 1 here. Okay, and we're going to go -1/3. So we're going to go down and right on this one. So down and right, and then down and right. We're off the grid, so I'm going to reverse it right here. And this one's going to be solid and above. So I'm going to go solid here. Use a straight edge, make it look better than mine. And I'm going to go green now. So this one's going to be above. Oops. Let's see. Let's get it. Oh, here we go. So here's my green region right here. Ooh. Okay, and where do they overlap? Well, they overlap. Well, it's kind of hard to see there. You know what? I'm going to do this. It's kind of hard to see. I thought colors would make it easier for you guys. So I'm going to use arrows. So go up here. So green is above. And then red, the one in red, this was above too, this way. And it's where they overlap, okay? Where does the green overlap the red? Okay? And that happens above this dotted boundary line here, and it's above both lines. So my solution region is all through here. Okay, in the blue. Okay, there's my solution region. It's where they intersect. Okay, so where the arrows overlap, where they intersect. Okay, not here, not down here, not over here, just above both lines. Okay. All right, and then you try number 42 and check your solutions in the back. Okay, now these, I'll do one more here just because these are in standard form. So let's take my work down here. So 3x plus y greater than 2, subtract 3x. We'll do them side by side. And y is greater than negative 3x plus 2. So this is A now, okay, in red. So negative 3 for slope, you got to go down 3, right 1, starting at 2. So down 3, right 1, reverse it. It's going to be right here. It's going to be dotted and above. That's the greater than symbol. Okay, so dotted and above. No. Okay, so go above. And then on this one here, the second one, 2x minus y is less than 3. Subtract 2x. And you get negative y is less than negative 2x plus 3. Divide both sides by negative 1. And switch the inequality to greater than. So y greater than 2x minus 3. Okay, so we're going to go starting at negative 3. We're going to go up to right 1. All right. And then it's going to be dotted and above because of the greater than symbol. So let's go dotted here. And then go above. And it's where these two overlap. Okay, and they clearly overlap in this region right here, in between the lines. Okay, where does the red overlap the blue? Okay, it overlaps in here. So this is the solution region. All right, and you can do number 44 and check it with your solutions in the back. Okay, now let's get to the algebra here. Okay, so you got to solve by substitution and then elimination. Okay, so on this one here, we're going to substitute y equals 5x minus 3. We've got y, we know it's 5x minus 3, and we substitute it in for y. And so I get negative x minus 4 times y, which is 5x minus 3. All right, and that's equal to 12. Okay, sorry for that. Let's continue here. So distributing through the negative 4, we get negative x minus 20 x here plus 12 equals 12. Interesting problem here. Okay, so on this one here, we get a combined like term. So negative 1 and negative 20 is a negative 21x plus 12 equals 12. Subtract. And you get negative 21x is equal to 0. Negative 21 times 0 is 0, so x has to be 0. And then you have to substitute back. So we take this answer and substitute back in. And y is equal to 5 times 0 minus 3. So y is equal to 0 minus 3, or negative 3. So my solution is always x comma y. So in this case, it's 0 comma negative 3. And that's how you handle the substitution method. This one right here is even easier because all you have to do is say, hey, we know that y is negative 8 here. So you got negative 8 is equal to 2x minus 12. You got to love it. There's not much to do. You just got to solve for x. So let's add 20. 20 minus 8 is 12. And 12 equals 2x. All right, 2 times 6 is 12. So x is 6. And since y is already negative 8, we already know the solution. All right, so it's 6 comma negative 8. Now, elimination method is a little bit different. You wanna eliminate a variable. Okay, so you look for opposites. So you look for opposites. All right, and I see a couple opposites right here. And when you do, you add equations. All right, add equations, so I get 0 here, and I get 7y minus 4y, or 3y, is equal to 9. 3 times 3 is 9, so y is equal to 3. And then I find x. I got to find the other variable here. So I'm going to use this equation here. So let's just use this one. So 9x plus 7y is equal to 3. I know y is 3, so I have 9x plus 7 times 3 equals 3, which gives me 9x plus 21 equals 3. And after you subtract 21, you get 9 times x is equal to negative 18, divide by 9, and you get x is equal to negative 2. So my solution on this one is negative 2 comma 3. Right? Always x and then y. Now sometimes you don't have opposites, like negative 5 and negative 10 are not opposites, and 4 and negative 1 are not opposites. So you have to create opposites. Alright, so let's create opposites here. The opposite of negative 10 is positive 10. So if I multiply both sides by negative 2, I can do that. So negative 2 times 5x is 10x. Negative 2 times 4y is negative 8y. Excuse me, negative 21 times negative 2 is positive 42. Second equation, don't want to change at all because you want that to create opposites. So I'm just going to bring it over here and work with it. And then I'm going to add equations. All right, opposites always cancel to 0. So you have 0 right here, 0 minus something. So you have 0 minus 9y here is equal to 36. All right, divide both sides by negative 9. All right, y is equal to negative 4. And then you substitute back. You got to find x here. And then when you do, you take y here and you substitute it in. So let's do that. So negative 10 times x minus a negative 4 is equal to negative 6. Simplifying, you get negative 10x plus 4 equals negative 6. Subtract 4, and you get negative 10x equals negative 10. So x is 1. So my solution here, excuse me, is 1 comma negative 4. So, you know, you got to use a lot of algebra, right? You got to practice. All right, this is all semester 1, by the way. Okay, a lot of concepts. Find the slope. Okay, slope is rise over run. That's the key concept. So we're going to go down 3. Okay, right 1. So my slope here in this case is negative 3 over 1, or negative 3. On this one, if you go from point A to B, you got to go up 1, 2, 3, 4, 5. So it's up 5. And then you got to count to the right. 1, 2, 3, 4, 5, 6. So it's right 6. That's positive. So this is positive slope, negative slope. Lower right is always negative. Upper right is always positive. So in this case, you have 6/5. Okay? Oh, excuse me. Come on, Ainsworth. This is rise here, and this is run here. Got to think about it. 5/6. Don't do what I just did, okay? Always rise divided by run. Sorry. Okay. By the way, 6/5 is the most common mistake. And I made it right there, right in front of you guys. So slow down and check your work, okay? Up and down is rise. Left and right is the run, okay? Okay, now if you want to find your slope, you have to use your slope definition. So it's y is equal to y2, all right, y2 minus y1 divided by x2 minus x1. Got to find the definition or use the definition of slope. So I'm going to line them up vertically here. All right, line them up vertically and subtract up. All right, always subtract up. You guys remember I told you guys to line them up, subtract up. Why? Because x's always come first and then the y's. Okay, so my slope here, I'm going to start with the y coordinates. I got negative 3 minus a negative 15 divided by 2 minus 14. Okay, I'm going to simplify a little bit. Double negative up top. 15 minus 3 is 12. All right, 2 minus negative 14 is negative 12. So my slope here is negative 1. Okay? Always check your work and check your answers in the back. Okay, and you could do number 52. Okay, on this one here, same thing, find the slope, which means you got to get into slope-intercept form, y equals mx plus b. So basically, you have to solve for y. Okay, so let's do that. Let's subtract 4x. And you get 3y is equal to negative 4x minus 3, dividing through by 3. And we get y is equal to negative 4/3 x minus 1. So my slope is right here. So my slope on this case is negative 4/3. All right, negative 4/3. And again, you can do this one, do number 54 the same way. Okay, you got to solve for y, look for the slope. There's your result. Okay. Now we are in chapter 6. Chapter 6. So take out your chapter 6 notes. All right. All right, and this is use section 6.1, 6.1 notes. All right, 6.1 and 2 actually. All right, so the very first thing we want to do is regroup. Okay, 4 times 3 is equal to 4 times 3, and then x squared, x to the negative 2, times y to the negative 2, times y to the second. So you regroup step 1. Okay, step 2, and if you look at your notes, we did this, by the way. Okay, I'm doing it the same way as I taught you guys. All right, 4 times 3 is 12. This is 1 over x squared. You got to rewrite. And this is, you got to add your exponents right here when you multiply like basis. So this is y to the negative 2 plus 2. So, which is 0. Let me just put 0 right there. You get 0 power. Now remember, y to the 0 power is 1. That's the 0 power rule. Okay, as long as y is not equal to 0. Okay, any variable to the 0 power is defined to be 1. Okay, and so because this is just 1, all right, what do you get? Well, you get 12 times 1 is 12 divided by x squared. All right, you want to write with positive exponents and write it as a single fraction or a single term. Okay, 56, same idea. You got 4 times, but it's no other. That's the only constant. You got to multiply your m's together, so m squared times m to the 4th times n here in the third group times n to the negative 3. Notice that n is to the first power there. So what do we get? We get 4 times m to the 6th power times n to the negative 2 power. What does that equal to? It's 4m to the 6th times n to 1 divided by n squared. And you rewrite that as one fraction, so you get 4 times m to the 6th divided by n squared. Okay, look at the numerator. Look here. 4 times m to the 6th times 1 is just 4m to the 6th divided by n squared. Okay. This one here, you got to raise each factor to the power. That's the key idea. Raise each factor to the power. Key concept. So this is equal to 3 to the negative 4 times y squared to the negative 4 power, which gives you 1 over 3 to the 4th times y to the negative 8 power, which is 1 over 81 times 1 over y to the 8th. And so you get 1 divided by 81 times y to the 8th. Okay, and that's number 57. Okay. Okay, this is 1. You got the 0 power rule right here. Okay, 0 power rule. Anything raised to the 0 power is 1. So you got to look right there. It's easier than you think. Okay, on this one here, simplify first. Okay, and what do you get? You get this is equal to 1 in the numerator. All right, and there's an x squared in the denominator. So 1, let me see, 1. Let me see. So 1, and let me see, y squared divided by y to the 4th is, don't even need the 1 here. So we have y squared divided by y to the 4th. Get 1. Let me start off with the x's. Let me go alphabetical. I got 1 divided by x squared. And then here you get y squared divided by y to the 4th, which is y to the 2 minus 4. So you get 1 over x squared times y to the negative 2. You know what? I'm going to do it this way. I could do it this way, but I'm going to do it the easy way for you guys. Simplify first. Y squared means y times y. X squared can't be simplified with anything else because there's no other x terms in the numerator right there. And y to the 4th is y times y times y times y. So now notice something here. Y divided by y is 1. Y divided by y is 1. And so in the numerator, you only have 1. 1 times 1 is 1. In the denominator, you got x squared, all right, and this y times y, which is simply y squared. So in this case, it probably is going to be easier for you guys is to expand and simplify, other than, rather than doing the rules there. Okay, on this one here, let's separate it. Okay, on this one, it'll probably be a little bit easier. I see 1/4 is my first group. I've got this to handle here, so I got x to the -2 minus, okay, -3, got to subtract exponents, times y to the, well, y to the third divided by y to the third is 1. So don't even take that into account. Okay, so what do we get? We get 1/4 times x to the, oh, what is this? Let me see. Let's add the opposite here. 3 minus 2 is 1. Ah, this one's simple. 1/4 times x is simply x divided by 4. So here you want to subtract exponents when you divide like basis. Okay, so here it's 2 to the 0 power divided by this. So it's 0 minus a -3. So that's 2 to the third power, or 8. Same idea over here. 4 to the -2 minus the -4. You have to simplify. Double negative. What does that equal? You get 4 to the 4 minus 2, which is 2, and that's 16. Okay, power to power, multiply exponents. Power to a power, if you read your notes, all right, you multiply exponents. So this is equal to 2 to the 4th power, or 16. This one's equal to 3 to the -4 power, which is 1 over 3 to the 4th. If you use your powers, you multiply 3's together, 3, 9, 27, 81. Here's your side work, and you get 1/81. Okay. Now this one here, you have to add exponents. So you have 4 to the 1 plus -4, which is 4 to the -3 power, or 1 to the 4 to the third, and then you use your base 4 powers, so 4, 16, 64, so 1/64. And on this one here, we get 2 to the 0 plus -2, which is just 2 to the -2 power, or 1 over 2 squared, or 1/4. Okay? So that's 6.1, section 6.1 and 6.2. Now let's move on, section 6.3. So this is section 3 in your notes. Okay, and this one here we add, and this one over here we subtract. So we're going to regroup. We got, my first group is, we got cubes. The highest degree is 3, so I see a 2r cubed here. 2r cubed. I see a minus r cubed here. Then the squares. So that's positive, so 7r squared plus 8r squared. And then my third group is just the minus 7r. So combining like degrees, okay, third degrees first, so 2 minus 1 is 1, so we have r cubed here, 1r cubed, plus 7 and 8 is 15, so 15r squared minus 7r. Okay, so you want to regroup and simplify. Okay, now this one's a little bit different. You want to distribute through the negative first. I'm going to put that in red. So I've got 7a plus 2a squared, and here we go, minus 7a. Think of it as a multiplication problem. -1 times 7a is -7a. And then -1 times -3a squared is a positive 3a squared. And -1 times 7, guess what? That is a minus 7. So you got to distribute through the negative first. Okay, and then regroup. So my squared terms. So 2a squared, and then I have a plus 3a squared. And then I see 7a and a minus 7a, they cancel. And then I see a minus 7. So this one actually is fairly straightforward. I get 5a squared minus 7. And that's 68, okay? Now, then we get into, I think it's section 6.4 here, I think. So you can check your notes there, because here we start multiplying. So distribute. So this is equal to 15x x to the fourth plus 18x to the third. Okay, now in this one, you have, when you multiply 3x cubed times 5x, it's 15. 3 times 5 is 15. And then when you multiply x cubed times x, you get x to the fourth because you add the exponents. That was the thought process there. Same thing here. When you distribute here, you get 49k minus, all right, 35. You guys can do 70 and 70, 71 and 72. On this one here, you want to use the FOIL method or distributive property, and when you multiply 4 times, multiply 4 times. All right, first, outer, inner, last. Okay, so 4v times 4v, that's 4v squared. 4v times negative 4 is negative 16v. Negative 6v here, and then a plus 24. And you want to line up like terms. So what do we get? We get a 4v squared minus 22v plus 24. Okay, so you want to multiply 4 times and line up like terms. Okay, always line up like terms. I'm going to do one of each here. You guys can do the right column on your own, and you can check your work with the answers I provide. Okay, so got to multiply 6 times here. So 6x times x squared would be 6x to the third. 6x times a negative 3 is a minus 18x. And 6x times negative 2 is a minus 12x. Distributing the negative 7, I get a, oops, I forgot a square there. 6x times 3x is 18x squared. There we go. Negative 7 times x squared is a negative 7x squared. Negative 7 times negative 3x is positive 21x. And then a negative 7 times negative 2 is a positive 14 here. So what do we get? We get 6x cubed, and then a minus 25x squared. 21 minus 12 should be 9, so plus 9x and then plus 14. Okay, so just checking here. All right, looking good. So you got to distribute and line up like terms. Very important in these, all right, especially this trinomial example. So here we go. This is a big one. So I got to distribute the 7x squared. So 7x squared times 4x squared is 28x to the fourth, because you got to add your exponents. X squared times x squared is x to the fourth. And then 7x squared times x is 7x cubed. 7x times a negative 4 is negative 28x. Distributing through the 2x, here you got 2x times 4x squared. 2 times 4 is 8, so 8x cubed. It's positive, so line up the cubes. 2x times x is 2x squared. Oh, shoot, man. There's a 28x squared here. So 2x times x is 2x squared. And then 2x times a negative 4 is a negative 8x. Okay, and lastly, distributing through the negative 7. So negative 7 times 4x squared is a negative 28x squared. Negative 7 times x is just a negative 7x, and then negative 7 times negative 4 is positive 28. All right, and then what do we get? We get 28x to the fourth plus 15x cubed. Let me see. So on this one here, let me see, a negative 28 and negative 28 is negative 56, and then plus 2 is negative 54, so negative 54x squared minus 15x, and then plus 28. There we go. Okay, and like I said, you guys can challenge yourself on the next ones and check your work, but it's done the same way. It's really important that you line up the like terms, all right, and go slow and pay attention to things. I'm going to do this one here because something cool happens in 79 and 80. When you multiply here using FOIL, you get 4x to the fourth. All right, and then minus 2x. And distributing through the 1, you get plus 2x, and then a minus 1. So we have 4x squared. Middle terms cancel to 0. All right, so 4x squared minus 1. Okay, you try number 80. Now, you got to be careful here. 3m to the minus 3 to the second power means 3m minus 3 times itself. And then once again, this is the FOIL method here. Be careful, you just don't square both the terms. That's the most common mistake. All right, so you get 9m squared minus 9m minus 9m and then plus 9. Notice that the middle terms do not cancel out. All right, you get a negative 18m in the middle. All right, and so be careful on these. Okay, they're whenever you square things, you means that you multiply by itself. Okay, and the last portion here, division problems. You want to divide all terms by the denominator. Divide all terms, all right, by the denominator. Okay, so here we go. So this is equal to 30 x cubed divided by 6x squared plus 30x squared divided by 6x squared plus 3x divided by 6x squared. Now you simplify. Okay, so here 30 divided by 6 is 5, x cubed divided by x squared is x. Here you just get 5 because these cancel, right? Boom, boom, that's 1. And then divide here and you get 1/2. 3/6 is 1/2. And then x here cancels out with one of them here, leaving 1 remaining. So you get plus 1 divided by 2x. So plus 1 over 2x. Okay, simplify this. So x divided by x squared is the same thing as x divided by x times x. And notice that you get 1 over x. Okay, and you do number 84. Now, this is long division. Okay, so here you want to show your side work. So let's take x squared minus 4x minus 32. Let's do our side work over here. And divided by x minus 8. And you always want to divide first term divided by first term. So that's x squared divided by x. All right, which is x. Put up there in the quotient. X times x is x squared. X times negative 8 is negative 8x. Now you add the opposite. Right? Add the opposite. And these always cancel out to 0. And you get 8x minus 4x, which is 4x, and bring down the minus 32. And repeat. Step 2. First term divided by first term. 4x divided by x is 4, and it's positive, so you go plus 4 up here. And then you multiply. And then 4 times x is 4x. 4 times negative 8 is negative 32. And when you add the opposite, which is the same as subtraction, you get remainder 0. So our result is x plus 4. There's your result. Now this one here, same idea, but you have a cubic. So I'll do one more just because it's a review video. So we're going to take this cubic polynomial, 3x cubed minus 20x squared minus 58x here, minus 40, and we're going to divide. And we'll do a little side work here. So step 1. So 3x cubed divided by x is 3x squared. So 3x squared, and then you multiply. So you get 3x cubed minus 27x squared here, because 3x squared times negative 9 is negative 27x squared. Add the opposite, or change the signs and add, same thing. And you get a remainder of 7. 27 minus 20 is 7, so you get 7x squared, and then bring down this minus 58x. And now repeat, step 2. 7x squared divided by x is 7x. So put that up in the quotient, multiply. 7x times x is 7x squared. 7x times negative 9 is negative 63x. Change the signs, or add the opposite. And 63 minus 58 should be 5, so you get 5x here. Bring down the minus 40. And then step 3, first term divided by first term gives you 5. And then 5 times x is 5x. 5 times negative 9 is negative 45. And then add the opposite, or change both the signs and add. And you get remainder 5. So remainder 5 here is called a remainder. Okay, and so what we do is we go plus 5 divided by x minus 9. And that entire thing is the answer up here. It's called the quotient. There's your result. It's called the quotient. Okay, it's the answer to the problem, guys. That's what it means. Okay? And then, of course, you can do number 87. Okay, and that's it, my friends. Okay, you do the rest and get good. And then I will see you during the week and also on your final. Okay, this is a review video. So use it to your advantage. I did most of the problems, not all, because you're expected to do it and check your work. And I gave you all the answers. So do your best, and I'll see you in class.